Good morning or good afternoon, everyone. Today we're going to be going over our calculator skills number 2 using the Desmos calculator. So once again, if you don't know how to get the Desmos calculator, all you have to do is Google it and you can find the Desmos calculator. Put star edition or star version and you can go ahead and find it. Click on the star version or whatever state you have in Algebra 1. You can click on the calculator version and it will give you the one that's approved through your state assessment. So today we're going to be going over calculator skills number 2 aligned to our STAAR assessment in Texas. So we're going to be going over a couple of problems. So let's go ahead and get started. Number 1, given 4 open parentheses 0.5 n minus 3 equals to n minus 0.25 open parentheses 12 minus 8n. We want to know if n is equal to 3, whether that is true or whether that is false. So what we're going to do in this skill, we're not going to solve the equation. We could solve the equation using the distributive property and then doing all the math. But purpose of this one is to help you practice your calculator skills. So what we're going to do is we're going to be inputting via the calculator. And I'm going to show you the n. The n here is 3. And we're going to check to see if this side is true or false. And on this side, we are going to check it, and we're going to determine whether it is true and false. If we look at number 2, it is the same problem with the parentheses missing, but same problem. So the way I handle these calculator skills is I give you the identical problem. Two identical problems or very similar problems. So what I would recommend is for you to see how I do number 1, and then you pause the video and try number 2 by yourselves. Then of course you see how I do number 3, and then you pause the video and see how if you can do number 4 by yourselves. So for practicing our calculator skills, we are going to be inputting right here, and I'm going to show you. And once you get the hang of it, you do not have to do this work, but it is 4 open parentheses 0.5 times 3 minus 3. So that is exactly how you input it. So let's go ahead and input it into your Desmos calculator. So we're going to get the keyboard and we're going to do our math. We are going to do 4 open parentheses 0.5. And then of course we're going to multiply times n. What is the value of n? 3. So we're going to multiply times 3. And then we're going to subtract 3 and then close our parentheses. So if you see the value, it does give us -6. So we're going to check to see if the other side is true. So in place of n, I'm going to be inputting the number 3 because I'm giving you that the n value is 3. So right here, we're going to put on the second one, it's going to be 3. And then you're going to go minus 0.25. Open parentheses. We're going to go ahead and put 12 minus 8 times n. And the n value is 3. We're going to close the parentheses and the value is 6. So 6 does not equal to 6. So unfortunately our number 1 is a false statement because 6 does not equal to 6. And for those of you that have a multiple choice test, when you have A, B, C, D, you can also check out to see if both sides are equal if you do not want to solve the problem. But for our practice, it's going to be our calculator skills that we are practicing. So I'm going to go on to number 2. Given the same exact equation, so I'm going to practice my inputting and I'm going to say this time I want to know if it's true or false given that n is equal to -9. So I'm going to go ahead and take these away so I can start practicing. I'm going to go ahead and input wherever n is. I'm going to put a -9. And wherever n is, I am going to put a -9 and a -9. So let's go ahead and practice the first part of our equation. And then we're going to go ahead and put 4 open parentheses 0.5 times the letter n, and the letter n value is -9. You're just going to input it the way it is, what the value of -n is, and then you're going to subtract 3, close parentheses, and then of course you're going to let Desmos do the work for you. So then we have 4, open parentheses, 0.5 times -9 minus 3, which gives you a value of -30. So we're going to try the next one where we're going to check to see if it is equal. So we're going to get into our Desmos and we're going to check right here. We're going to go ahead and put -9 in place of n. So it is going to be, and let me go ahead and put it right here so you can see it. I'm going to go ahead and input -9 minus 0.25, and there's no need to worry about our order of operations because the Desmos does everything for us. And then let me move it a little. There we go. And then we're going to go ahead and put right here. Go ahead. Okay. No technical difficulties, but we're back on. So I'm going to go ahead and put -9 minus 0.25, open parentheses, 12 minus 8 times, what is the value of n? The value of n is -9. I'm going to close my parentheses, and the value does give us -30. So once again, is -30 equal to -30? And that is correct. So our statement here would be true. So it would be a true statement. You could go ahead and solve this equation via the distributive property, and then combining like terms and then simplifying for the answer. But for the sake of this practice, we are practicing, and if you do not know how to solve an equation, just by knowing how to input and knowing the calculator, you should be able to solve the equation without any issue at all. So now we're going to go on to number 3, and let me go ahead and erase. Given f of x is equal to x minus 6, quantity x plus 4, quantity in parentheses, find the axis of symmetry, find the 0, and find the y-intercept. Now looking at that equation, we're going to go ahead and input that one into Desmos, and you're going to kind of know that it is already a quadratic because we are looking for axis of symmetry, we are looking for a 0, and we are looking for a y-intercept. So I'm going to go ahead and delete this, and I'm going to delete this, and if I push the plus sign, I can see f of x here. I do not want to press the f of x expression because again, it just complicates things. So I'm going to leave it alone. Do not press the f of x. I know you want to press the f of x. Do not press the f of x. You can put y equals to that if that makes you a little happier. But if it doesn't, all you have to do is input this equation into your Desmos. So I'm going to open parentheses. I'm going to put x minus 6. I'm going to go ahead and close parentheses. I'm going to go ahead and open parentheses, and I'm going to put x plus 4. And as you can see on our Desmos, it already starts graphing our quadratic, which is our parabola. So I'm going to go to the very, very bottom, and I'm going to find my vertex, and my vertex is 1, negative 25. But again, it's not asking me for a vertex, it's only asking for the axis of symmetry. So in order to find my axis of symmetry, I'm going to circle my x. I know it is a U shape or an N shape. So I'm going to put the value of x is equal to the x value of the vertex. So the x value of the vertex is 1, and that is your axis of symmetry. Next, I'm going to find my zeros. Or before we go on to zeros, we can already find our y-intercept. By looking at that, the U-shaped graph, I can already see where it crosses my y-axis. And right here, it's going to cross my y-axis at 0, negative 24. So I can already input my y-intercept, which is 0, negative 24. Lastly, I'm going to find my zeros, and those is where my U shape does cross my x-axis. So I have two zeros here, and the first zero, if I click on it, is 6, 0, and my second zero is negative 4, 0. So I'm going to go ahead and put my x-intercepts as being negative 4, 0, and then of course 6, 0, and of course, is it okay to put my zeros as negative 4 and positive 6? Of course it is. So those are my two zeros, or my x-intercepts. So once again, I would recommend to pause the video and then try number 4 before you get on to doing this. So it's the same given equation. You're given a quadratic, which is x plus 3, x minus 5. You're going to find the axis of symmetry. You're going to find the zeros, and you're going to find my y-intercept. So again, if you want to try it by yourselves and then unpause the video and see if you got the right answers, you're more than welcome to do so. So let's go ahead and get on to solving it. I'm going to go ahead and input this equation right here. It's going to be open parentheses, x plus 3. Close parentheses, open parentheses, x minus 5. So automatically, I already see a quadratic forming. Our first one, number 3, was a minimum. This one is also a minimum because our vertex is at the very bottom. But again, I don't want to find my vertex. I know my vertex is 1, negative 16. I want to find my axis of symmetry. Since it is a U-shape, what is it going to cut? It's going to cut the U-shape in half. So what I'm going to do is I'm going to circle the x on the axis of symmetry. So I'm going to get it in blue, and I'm going to circle the x. So that gives me my axis of symmetry being a number, the x value of the vertex. I look at my x value of the vertex, and my axis of symmetry is x equals to 1. We already know that this is a minimum in our parabola. So again, I can very easily find my y-intercept, which is right there where it crosses my y-axis, and it is 0, negative 15. And then my zeros, I got to find where it crosses my x-axis. And again, another way to call them is also x-intercepts, which is negative 3, 0, and 5, 0. And is it okay to write my zeros as negative 3 and 5? Of course it is, because those are my actual zeros. My x-intercept is negative 3, 0, and 5, 0. Now, once again, if you're given linear equations and you want to find out whether they're factors or not, all you have to do is go in to that quadratic, and if it passes through the 0, they're factors. If it doesn't pass through my 0, they are not factors. So we're going to go on to the next problem, which is number 4. So we're going to go ahead and do number 4. 4 is just calculator skills. And looking at number 4, what I'm doing is, of course, I see this a little bit off right there. I'm going to change that to a G. There we go. I know our x value here is x equals to 15. So I got to put that as x equals 15. That is practically the only work I have to do. So wherever x is, I am going to put 15. And I might be tempted to push the plus sign and the f of x on decimals. But again, do not push it. There's no need to push it. So all I'm going to do is input this equation the way it is. And in place of x, I am going to put 15. So I'm going to go ahead and input it. I'm going to go ahead and put 1 divided by 2. And again, if I keep on going, I'm going to put it in the bottom, but I don't want to put it in the bottom. I can either put this arrow, push this arrow, or I can just click here on the screen. And then I'm going to open parentheses, and then I'm going to go 4 minus x. And what is the value of x here? It is 15, so minus 15, close parentheses. And then I'm going to go to the square because it's a quantity square, so I'm going to find the a to the square value. And then I'm going to do minus 3. So my answer, decimals did all the work for us. We didn't even have to think other than inputting the function into the equation. So again, 1/2, open parentheses, 4 minus 15, close parentheses, square, minus 3 gives us a total of 57.5, or for those of you that have common fractions, 57.5. And once again, if I want to know if 57.5 is the same as 57.0.5, then all I have to do is put 1 divided by 2, and it does give me 0.5. If we look at number 6, we are going to evaluate that one. G of x, given that g of negative 8. So we got to figure out what is the x value of this equation. So again, the only work we have to do, x equals to negative 8 this time. So you got to be very careful, because right there you have to input negative 8. So what I'm going to do is I'm going to clear my Desmos, and then I'm going to input wherever x is, I'm going to put negative 8. Don't forget the double negative, because if you forget the double negative, even Desmos does not get it right. We have to help Desmos out by inputting it correctly. So I'm going to be doing 1 divided by 3, open parentheses, 6 minus, and look at how it came out very, very wrong. I get confused, and that happens. Well, what happened? Well, I didn't press the sign, or I didn't press the arrow. So all I have to do is delete everything. I was at 1/3. I should have pressed this arrow right here. And then I'm going to open parentheses, and I'm going to go 6 minus 8. Because remember, we're subtracting 6 minus x. 6 minus x is 6 minus negative 8, because x is negative 8. Then I'm going to close my parentheses, and I'm going to go ahead and do the quantity square, which is the a square. And then I'm going to do the minus 4. And then that's going to give me the answer of 61.33333. So again, if I want to abbreviate it, I can put 61.333 with a small little line on top of the 3's. So once again, if you got that answer right, then you know how to evaluate the function given a value of a function. So let's take a look at number 6. This is another one where you're going to have to take the square root of both sides, and you're going to have to solve it, and of course you're going to come up with 2 answers, because once again, square means that we have 2 answers. But why do that if we're practicing our calculator skills? And we're going to go ahead and just input 1, and if it gives you the answer, then it is correct. If it doesn't give you the answer, then it's not correct. If it gives you the answer on the first one, then I would recommend that to input the second one. So I'm going to do the first one for you. Remember, the way we input this is we're going to go ahead and put 2 dot negative 6, and don't forget that dot, plus 8 raised to the square, all in parentheses. Now we're going to see if it gives us 100. If it gives us 100, then that is the right answer. If it doesn't give us 100, then it's not a right answer. And once again, this is the same equation we are testing, so there's no need to input it over and over and over. All you have to do is plug in the value, 2 times x, 2 times negative 6 plus 8, and then quantity square must give you 100. So let me go ahead and erase this. So then that way we can just use a calculator, and we can go ahead and input it into our Desmos. Okay, so let's test out the first one, negative 6. So I'm going to go ahead and input it one time. I'm going to input it by opening parentheses. 2 times what is x? Well, it's negative 6 here. And then I'm going to add 8 to it. And then I'm going to raise it to the quantity square. So the answer is 16. Once again, it doesn't give me 100, so this is not an answer. So then I'm going to go here, and I'm going to test the second one. So I cleared it, but I'm going to input it one more time right here. So right here in place of x, I am going to input negative 9. So I'm going to go ahead and put it in my trusty Desmos. I'm going to open parentheses. I'm going to put 2 times negative 9 plus 8. Close my parentheses, quantity square, and it gives me 100. So once again, this is a correct answer. So once again, if I have that answer, I also need to test the second one. So in order for me to test the second one, I'm going to have to also input the 1. So I'm going to go ahead and input the 1. I'm going to click right here, and instead of retyping it again, I'm just going to delete that. and I'm going to input the 1. So once again, I have 2 times 1 plus a quantity squared gives us 100, and this one also gives us a correct answer. So the correct answer is going to be letter B. But once again, sometimes I like to throw in 2 answers or 3 answers, so I also want to check the third one to make sure that it's false. So instead of the 1, I'm going to delete that, and I'm going to go ahead and put negative. And what is the answer? Negative 3, because I am testing this one out. And once again, it gives us 4. So that is not a correct answer. So our answer is double letter B, and that is our answer. So without even knowing how to solve the equation, I was able to come up with the answer, given a multiple choice test. So again, if you know how to do the next one, it's the same exact thing. I'm going to test A, B, and C. And remember that it has to give us 36. So I'm going to go ahead and start inputting the first one. So I am going to test the first one as it being 0. So I'm going to input it into my trusty Desmos, and I'm going to open parentheses. I'm going to go 2 times 0, and then I'm going to go plus 6, close parentheses, quantity square, and that gives me 36. So this does give me the answer. So I want to try the second one because, again, it has to also be correct for negative 6. So once again, instead of me retyping everything, I'm just going to put my cursor right there. I'm going to backspace it, and I'm going to go negative 6. And it also gives me 36. So I already know that letter A is the correct answer. But once again, I want to double check to make sure that these letter B's and C's are not the correct answer. So I'm going to go ahead, instead of negative 6, I'm going to test out 3. And if I put that one in, it gives me 145. It does not give me 36, so this one is a wrong answer. So B, I can eliminate. And then I'm going to try out C as negative 6. So all I have to do is come over here, put the cursor right behind it, and then put in negative 6. And it does give me 36. So this one is also a correct answer. But I got to test out the second one to see if it does give me a 36. Remember, both answers have to be correct. So I'm going to go ahead and delete that one. And I'm just going to put in 4. So 2 times 4 plus 6, quantity squared, gives me 196. Doesn't give me 36. So this makes this one false. So C is incorrect. So our correct answer choice is letter A. Once again, try to see if you can do it with and without the work. All you need to do is know how to input it into the Desmos calculator. So we're going to go to number 8. So once again, I am going to guide you through number 8. Now we're dealing with y equals negative 1.5x plus 30. This is going to go back to having a linear equation. And remember what we said about a linear equation are lines. So we are going to look at what the slope does give us. And right here, remember that we discussed that the number, when they're given in y equals mx plus b, that the letter next to the x, or the number next to the x, is our slope. So automatically our slope, or our rate of change, is negative 1.5. So we are asking for slope and we are asking for rate of change, the same thing. They mean the same exact thing. So our rate of change is negative 1.5. And you know that the line is going to be going down the mountain. So it's going to be going down, and we're going to see if that is correct. We already have our slope-intercept form, because our slope-intercept form is y equals to mx plus b. This is our y-intercept form. So all I have to do is input y equals negative 1.5x plus 30. And once again, my y-intercept is 30. But again, I'm going to go ahead and use Desmos to check our work for us. So one of the things that I do want to show you on this linear equation is that once you get 2 lines, well, no, this is 1 line. If you have 2 lines, it's going to be a system of linear equations. But I'm going to show you another way to find slope using a table format. But let's go ahead and input the equation. So we're going to input it as y equals to negative 1.5, which is our slope. And then I'm going to input x. and then I'm going to input positive 30. And of course, I'm going to see my line, and I'm going to take a look at the features of this line. I cannot find the line. There it is. I can see it's going to go down the hill, so that's my negative slope being there. It has 1, 0, and I'm going to click on it, and my 0 is right there, 20, 0, and that's also called my x-intercept. So if I want to say my 0 is 20, that is fine. If I want to say my x-intercept is 20, 0, that is fine. If I want to find my y-intercept is right there, 0, 30. So I have 2 points. So one of the things that I do want to show you is that even if I do not have, if I'm given 2 points and I want to find the slope without knowing that y equals to negative 1.5x plus 30, all I have to do is click on here. I want to input my table. I have 2 points. And my 2 points are my y-intercept as being 0, 30. I'm going to go ahead and input in my table as 0, 30. And I also have my x-intercept, and I'm going to find my x-intercept, and there it is. Let me click on it, 20, 0, x is 20, y is 0. So I have my 2 points, 20, 0. And then I'm going to press my little leaf. And of course, look at what pops out here. It is a linear regression. It's a linear equation. It gives us y equals to negative 1.5x plus 30, which is the same linear equation that it gives us. So even if we have 2 order pairs only, not a line, we can still find the slope by knowing y equals to mx plus b. Our slope is negative 1.5. But again, going back to the question at hand, because there's multiple ways to use Desmos to find the answer, to find your y-intercepts, and to find your slope. So I'm going to take away this table, and I'm going to shrink our Desmos. And the other question was, what is our x-intercept? I'm going to hover over this, and my x-intercept is 20, 0. And of course, they're asking, that is my x-intercept. My 0 is 20. So either answer is correct. I want to find my y-intercept. I take away my x-intercept. It is 0, 30. So once again, close parentheses, of course. So once again, that is how you find it using the linear form. So just knowing Desmos, you let the Desmos do the work. You let the Desmos do the work. We're going to go to number 9. Given that equation, we're going to find the 0, we're going to find the y-intercept, you're going to find slope rate of change, and you're going to find the slope-intercept form. Again, if you would like to pause the video, go ahead and pause it, try the work, and see if you get the right answers. But once again, let me go ahead and take you through the problem. First of all, I'm going to tell you, okay, slope-intercept form is already given to us, and it is y equals to 2.5x minus 20. Given that, we already know our slope, or our rate of change, is 2.5, because that is already in y equals mx plus b, which is this one. And remember, the m is the rate of change or the slope, and the b is the y-intercept. So we have a rate of change of being 2.5. If I want to find y-intercept, I look at this number. Since it is already in y-intercept form, it is 0, negative 20. You don't believe me? Go ahead and graph it on your Desmos. And of course, my 0 and my x-intercept, I would have to work it on the Desmos. So I'm going to go ahead and input this without the y. I can also write f of x, but I don't want to write f of x because Desmos goes crazy with the f of x. I like to do y equals 2.5x minus 20, or just inputting 2.5x minus 20. Both work. For the sake of time, I'm going to just input 2.5x minus 20. Gives me my linear equation, my line. I can find my 0 as being 8, 0, which is my x-intercept, 8. So my x-intercept is 8, 0. My 0 is 8. I want to find my y-intercept. All I have to do is manipulate the graph. And there it is, 0, negative 20, which is what I got in the first place right here. Of course, those are answers, and that is how you find given the y equals mx plus b. Okay, so let's get to number 10, and this is right here. I'm going to go ahead and fix it up. It is a -4, so you can look at the work, and the next one, it got cut off, but it is a 2. So I'm going to go ahead and erase this work right here. Okay, let's look at this power of a power. If you look at that at the very top, we have a power raised to a power. So I'm going to go ahead and draw my big division sign here. And then I'm going to look at the top one right here. And then I'm going to say, well, that's a power raised to a power. So when we do a power raised to a power, I'm going to go ahead and multiply 3 times -4, which gives me a -12. And of course, if you don't know how to do 3 times -4, I don't know what 3 times -4, you just input it into the Desmos, and you let the Desmos do the work for you. And it gives you -12, which is what we got. On the bottom, there's nothing there other than y equals to -5. And again, what we discussed earlier, we have y. So what we're going to do is we have division, so we're going to leave the y on the top, and then we're going to subtract the exponent. So all we're going to do is take -12 minus -5, and not just -5, it's got to be -12 minus -5. So I'm going to go ahead and input that into the Desmos. Because our powers of division, we subtract the exponents, so we're going to go ahead and do -12 minus -5. And that gives me -7. But one thing, and then I sometimes like to draw this line like that so I can know if I've finished my work or I haven't finished my work. Now, I can never have a negative power. So the way I change it to positive, I have to multiply it by the reciprocal, but the way we do it in class very easily, you just throw it to the bottom. It's in the numerator. You throw it to the bottom in the denominator, and or you throw it back up to the top and it becomes positive. So you're just multiplying and you're throwing it either to the top to the bottom. This one is y to the -7 is the denominator. I mean the numerator on the very top, and then there's an imaginary 1, of course, on the bottom. So it's y to the -7 divided by 1. And then I'm going to go ahead and flip it. So I'm just going to throw y to the -7, and it's going to become positive. And then, of course, I'm going to throw the 1 to the top, and it's going to leave it alone. And that is your answer. So that's all I do. If the negative is on the bottom, you just throw it to the top. If the negative is on the top of the division sign, then you just throw it to the bottom. If we go to number 11, it's also a power to a power, but again, it's going to be a little bit tricky. So I'm going to go ahead and do that because you have a power raised to a power raised to a power. So I'm going to do my big division sign. Here on top of the 3, we got to understand that there is an imaginary 1. So we have 3 raised to a power and x cubed raised to a power. 3 raised to a power is 3. 1 times 2 is going to be 2, and then x to the cubed raised to the second is going to be x through to the 6. Why? Because we multiply 3 times 2, and we multiply 1 times 2, which gives us that. Then at the bottom, I'm going to leave the bottom by itself, which is -5. So I'm going to put my equal sign. I am going to change colors. I'm going to draw my line. And then I'm going to say, well, 3 squared, what is 3 squared? 3 times 3 times 3 is 9. And if I don't know how to do 3 squared, not to worry, Desmos is here. All I have to do is go 3 raised to the square, and it gives me 9. And then I'm going to rewrite it, and I'm going to put x to the 6, x to the 5th. And then I'm going to put equals, because I like my steps, I like my process. Then I'm going to do my line, and then I have a pair of x's and a pair of x's. So I'm going to leave 9 at the top, and then I'll have my x with the x. I'm going to leave an x at the top, and down there it's like an imaginary 1. And I have a division of exponents, so I have x to the 6th divided by x to the -5th. So what do I know about my exponents? All I'm going to do is subtract the 6 minus -5, and that's going to give me the answer. All I have to do is input it into the decimals. 6 minus -5, and that gives me a positive 11. Since it is positive 11, I don't have to do anything to the problem because it's already positive. We don't have a negative exponent. So that right there is my answer. 9x to the positive 11. And then looking at my next problem, I am going to just be going over this one, assuming this U shape is opening outward and it's not stopping. We're going to be discussing domain and we're going to be discussing range. And once again, remember what domain is. And I want you to look at this graph. Our domain is our x value. And since it keeps on going and it keeps on going outward, assuming that it keeps on going that way and it keeps on going that way like this, it's going to keep on going. So is it 0, 1, 2, 3, 4, 5? My x values is everything on the number line. So I would put my x value. And of course, I would put less than or equal to -infinity, because of course it keeps on going to infinity and then to positive infinity. So it will be less than or equal to positive infinity. But another way to write the domain is all real numbers. Next, I want to find my range. Range is my y. So the way I do this is, what is the least y? I'm going to draw my line here. What is my least y? -5. So I got to put y is less than or equal to -5. Is that correct? No, it is not, because all our values on this U-shape are everything above the y, which is -5. So it can be -4, it can be -3, it can be -2, it can be -1. So the way we would write this is y is greater than or equal to -5. Let's read that to make sure we have our correct range. Our range is y is greater than or equal to -5. That is correct. So that is my range. My axis of symmetry is correct. It is a minimum right here. My vertex is 0, -5. We don't have to put it in decimals. Why? Because the graph was given to you. So once again, my vertex is 0, -5. So once again, let's get the trick for axis of symmetry. My axis of symmetry is x is equal to the x value of the vertex. What is my x value of the vertex? It is 0, so my axis of symmetry is x equals to 0. That cuts the parabola in half. And last but not least, I want to find my, or second least is, I want to find my zeros. First of all, I find my x-intercepts I have right here. 3, 0 and -3, 0. I have my -3, 0. This is 1, 0. And my second 0 is 3, 0. So my x-intercept is -3, 0 and 3, 0. So my zeros would be -3 and 3. And if I want to know my y-intercept, it's where my parabola cuts or intercepts the y-axis. My y-axis, my range is going up and down. It only intersects right here. And of course, that is also my axis of symmetry as being, not my axis of symmetry, my vertex, which is 0, -5. That is my y-intercept, and that is also my axis of symmetry. So once again, this is a harder problem to deal with, so we're going to go ahead and look at number 13. And of course, if you want to try it by yourself and try to figure out what the domain is, what the range is, what the axis of symmetry is from the work that we've done before, you can pause the video and then see if you got the right answer. So if you pause the video, now we're going to work the problem. So once again, is this a minimum? We have the vertex right here. It is 6, 3. Now we're going to look at this, and this is one of our first ones that this is going to be a maximum value. And why is it a maximum value? Because it is at the top of the hill. So once again, our max value is at the our vertex is at the very top of the hill, which is a U shape. And again, it is a max value. So the first thing, we are going to have to find our domain. Our domain, assuming the U shape keeps on going forever and ever and ever, and it keeps on expanding, our domain is signified by x is less than or equal to, of course, negative infinity, because it's going to keep on going to negative infinity, and to positive infinity. So is less than, x is less than or greater than, of course, positive infinity. And another way to write this is our domain is all real numbers. Next, we want to find our range. Our range is our y value. So I'm going to get this in red so you can see it a little bit more clearer. So our range is our y. So I'm going to look at my vertex being 3 as my y value. I'm going to look at the 3, and we got to really look at that and say, well, can we have 4 as a y? No. Can we have 5 as a y? No, because they're not part. So can I have 2 as my y? Yes. Can I have 1? Yes. Can I have 0? Yes. Can I have negative 1? Yes. All the way down to negative infinity. So all my y values are anything less than or equal to 3. So the way I would write that is I would say y is less than or equal to 3. Now let me check it to make sure I did it correctly. Y is less than or equal to 3. That is correct. So that is my range. Next, I'm going to find the axis of symmetry. And again, it is my x value of my vertex. I'm going to look for my vertex, which is a maximum right here. And my x value is 6. So my axis of symmetry is 6. And my last item I'm going to check is what are my zeros. Well, first of all, my x-intercepts are 4, 0 and 9, 0. So let me write down my my x-intercepts. It's going to be 4, 0 and 9, 0. Let me check to make sure it's correct. 4, 0, 9, 0. So my zeros would be 4 and 9. Now, I know it's not here, but what is my x-intercept? Well, my x-intercept is 4, 0, 9, 0. But what is my y-intercept? So I'm going to look for my y-intercept. Well, it's not in the graph. It's not there, but I would be able to find it. Eventually, it would cross the y-axis, but for the sake of time, we're not going to find the y-intercept because then we have to construct the equation, and then after that, we're going to have to find the y-intercept. So just you know that it is wherever it crosses the y-axis. So moving right along to our last two problems, 14 and 15. Given f of x is equal to 3, open parentheses, x, 3 times 5 raised to the x. So is this graph a linear, an exponential, or a quadratic? Is it linear? No, it's not linear. Is it exponential? Yes, it is. It's got that small little x that we were talking about. So whenever it has a small little x, that is an exponential function. Is it a quadratic? What would change if this was a quadratic? We would, instead of that tiny little x, we would have a tiny little 2. So once again, if we look at 15, it is exactly the same. This is an x, just so you can know. And we're going to look at both of them the same. So if you want to try it out, you can go ahead and try it out. So once again, I'm going to go ahead and input this on my Desmos calculator. So I'm going to split screen it. I'm going to move this equation right here. And I know you're going to be very tempted to come here to the plus sign and click that f of x, but don't do it. Don't worry about it. Just input the equation the way it gives it to us. So we're going to go ahead and input. We don't have to put f of x. All we have to do is put 3 times, or we don't have to put times. We can just open parentheses. We can put 5. And how do I get that? Well, I have to close my parentheses. How do I get the small little x? Well, I can't get the 2, so I gotta use this function. A raised to the b, press that function, it raises the little power, and all I'm going to do is put it to the x. And there it is. There is exponential. So I'm going to look at this, and it tells me to sketch. So I'm kind of going to look at it really quickly so you can see that this is an exponential function. It's not a line, and it's not a U shape. It's kind of like an open, and then it keeps on going upward very, very fast. The only thing that we can see here, it approaches a number, so that's called an asymptote. But for the sake of this example, the y-intercept, just by looking at it, is 0, 3. 0, 3 is my y-intercept, and that is the only thing I am asking on the question, to sketch it and to find me my y-intercept. So the way I would sketch it, I would get a point right there, and that would be 0, 3, close. And then of course the sketch would be something like this, and then it's going to go upward. And why is it going to go upward so fast? Because it's an exponential function. And when we get ready to start doing the table on an exponential function, remember that the table that we do, we always look at linear. Whenever you have something called an exponential, you're going to go ahead and switch the function. Instead of linear regression or quadratic regression, you're going to be putting exponential regression. So once again, that is a sketch or a rough sketch of our exponential function. So we're going to do the same thing with our next problem. So our next problem, if you want to try it out, you can go ahead and try it out. Number 15, and this will be our last one that we are going to do. So first of all, is this graph linear? Of course it is not. It's not linear. It's not 4x plus 5. Is it exponential? Does it have that small little x at the very top? And it does. So it would be an exponential. Is it quadratic? Does it have the tiny, tiny little 2? No, it doesn't. It has an x right there. So I'm going to go ahead and graph it. So I'm going to just input it the way it comes. And if I want to put y, I can put y equals to 4, open parentheses, 6, close parentheses, raised to the square. No, we're going to raise it to the x. So how do we find that figure? If we raise a to the b, and we're going to go ahead and click it, and then we're going to input the x, and it gives us our exponential function. I'm going to go ahead and find my y-intercept so I can graph it. So it's about right here, and it is 0, 4, and then I'm going to sketch the graph as going upward like this. Do I know my y-intercept? My y-intercept is 0, 4. So that concludes our calculator skills number 2. And once again, I hope you were able to guide yourself on some of these questions. And just like we did in 30 to 40 minutes, we were able to do 15 questions that normally would have taken us hours and hours to do, with all the work and all the step-by-step process. And what is going to be the key to our math? Let Desmos do the work. You always let Desmos do the work for us. Thank you for your time, and if you have any questions, don't hesitate to let me know.